Let's see, can you guys hear the audio? It didn't come back. Is your audio on or
Is on my audio? My
speakers are up?
speakers up.
Okay.
This one was close. Yeah, this one.
No,
Only that one. Maybe they can hear.
can you guys hear Marcel? Can you hear us?
Yeah, I can.
Okay, you guys, sorry about the delay. Maobing 2's here. So he's an expert in biodiesel. He's been doing it quite a while, right?
Yeah.
You were at in Canada at the
Yeah.
at the Paper
Yeah.
Institute or something
Hope and Paper Research Institute of Canada
in
Montreal.
Montreal?
Yeah.
Okay, and then went to Atlanta or something,
Yeah, I went to the South Auburn University.
and then like came here after that, or?
Yeah, I came here.
Okay, yeah, so he's like, I don't know, you've been doing it a while, so
Yeah.
you got a big group, right?
Yeah.
How many students?
Not too much. I have two postdocs right now, 2 students.
And then undergrads work with you a
Yeah,
lot,
I'm
right?
going to working with me.
Any of you guys working with him in this lab, or? Because he's got a big.
Not right now,
so-
but the previous year I have some undergrad student from KMU working with me in the summer.
Yeah, every time they go to your lab, there's like a
Yeah.
bunch of undergrads like hanging out,
Yeah.
making biodiesel.
Yeah.
So anyway, I gotta sit over here.
That's great.
Yeah,
Thank you. Yeah.
Thanks for coming.
No problem. Okay. Thank you, guys. And I'm Beaucage. I'm actually faculty in this department. I'm mainly in the environmental engineering. So for my research, mainly on the biofuels and maybe related a little bit with biodiesel, there's a little bit difference. So mainly on the biofuels, liquid biofuels. So actually produce that one from renewable biomass. I don't know. You guys in the it's first year or second year? Third year. So and then your last year you need to do the capstone project. Actually, almost every year, some of you guys actually selected this kind of project to produce the biofuels or byproducts from the renewable biomass as a capstone project. So I think I have maybe more than 4 groups for their capstone projects. Okay. So this one I just show you some background information, and also I will show you some videos. Hopefully, I still can play here. Okay. It's actually I recorded. So something I want to see a big facility we built it from our DOE project. So first one for the gasoline price, I made this one this morning. So this is the pictures of the gasoline price right now across the US. Of course, maybe on this side of California, their price is higher. And this is the Ohio, and then on the east side also relatively high. So, but roughly it's about between the $3 to $4 or maybe $5, right? This is the range for us. So actually, what's the current price, you guys, for the gasoline? Do you know how much? So I put that number. Yeah. It's about 290, but it depends on cities, right? If you add it in the side of Cincinnati or outside of in Mason, it would be different price. So I drove to the Costco and then added my gas. So it's about $3 right now. It's not that bad, also not that good actually. Hopefully you guys can tolerate that. And also, you know, the gasoline we added is always have 10% of the ethanol inside, right? So always have 10% ethanol. Okay. So this is the background information about the bioenergy research. So in the US actually originally, okay, we probably right now we don't spend this one, but we spend on other things, okay. So we spend about $1 billion per day for the original for foreign oil, like from outside. And also this originally created problems because the disruption in the oil supply and also created the economic uncertainties and also affected the national security for the US, okay. So this will show you the dollars. Actually, the reason I collected numbers relate to the entire Panama Canal project. This is actually $14 billion. That's the 2011 dollars. Okay, so we spend about $1 billion per day. So that's how much we spend. Okay, and then this one is a space program. Originally, entire Apollo project is 157. That's not much, right? And now annual deficit originally this is about 2012, yes. So we have about $326 billion of the trade deficit for the petroleum products. But right now we are actually in much better shape. So it's different now. But energy is still the big issue for us, okay? So the drivers of biofuels and the bioenergy, so first one is increase the energy security and reduce the emissions depending on the outside of the foreign oil, so that's the first one. Second one is country is a kind of topic, I think some of you guys maybe not from the engineering or from other department, but both actually from environmental or chemical, we know we have to reduce the greenhouse gas emissions, the GHG, right? So these biofuels can help to reduce the greenhouse gas emission. And also the third driver actually is to increase the sustainability of liquid fuels. We all know the crude oil will be consumed one day, right? So we have to generate new fuels for it, right? Otherwise, everybody can drive the electric car, right? You can drive. But I still like the regular gasoline car, okay? So created the new job opportunities for us. That's good part. That's why you guys are here to learn something new. And also we have the 1 billion tons of renewable biomass, but I will show some interesting pictures for you guys. So this is the petroleum imports and exports. Actually, this one actually from the 1950s actually to this one actually 2020. So the blue line indicator actually is the petroleum's consumption. I think this one, yeah, consumption. So you can see about from 6, this is the million barrel per day. Right now we have around in this range, it's about 20 barrel per day, 20 million barrel per day, okay? No matter it's come from outside or from the US or from Canada, okay? So now this is the consumption, and also you can see the difference. We have this one is green one actually is indicated is the imports from outside. So original was increasing, and especially 2020, 2005 or 2007, that's actually hit the highest. And now it's dropped a little. So we still maybe import about 10 million barrel per day. But our export, we also export. Let me see why we need export. The petroleum products. We get the oil from outside, but we do refinery, and then we actually produce the products, ship outside. Actually, exporting right now is pick up relatively high. It's relatively reach to maybe to 8 to 10 million barrel per day right now. So that's a big picture. Okay, you can see. But the net imports, this is the red one, red curve. So the from 2005 to 2020 right now, the net imports actually dramatically reduced. So that's a big situation. But that's only one side of the story, right? That's related to the products, imports, and the exports. So we also need to worry about the CO2 emissions. So this shows you pictures also from 1970s to 2015, even currently similar. We don't change much. So this is the countries actually from they produce most significant amount of the CO2. Do you guys guess how much CO2 we produce in the US? Guess a number.
Say global or US?
US. Totally. 1 year.
We had like 30 million?
More than that.
30.
So this is the 1,000 million tons of CO2. Okay, units. So this is at the bottom. This dark blue actually is from China, from Asia. China right now reach about 10. This one is 1,000 million. That means billion. So 10 billions for the China right now. For the second part, this is the illegal light blue. Actually, is the US. United States actually is not changing much from 1970s to this is 2015. Actually, even right now, 2023 is same. So we reach about 5 to 6 billion tons per year released every year. Okay, so that's we need to know roughly that numbers. Okay, so we needed to reduce the numbers hopefully. So and also for the fuel ethanol, right now back to the ethanol. So why we need to produce the ethanol? We have plenty of resources. Actually, US produce a lot. So this is the curve actually to show. I heard some people from Illinois, right? So maybe you guess how much actually Illinois produces the ethanol. This by 2020. This is from corn. This is from corn is primary feedstock of ethanol in the US. So first, of course, is from Iowa, right? Who come from Iowa? Everybody? You come from Iowa? Wow, that's far away. Yeah, it's colder right now. Okay, hopefully not that cold compared to Minnesota. Maybe they're similar. I don't know. Okay, so this is Iowa actually they produce a lot. So this will show you, this actually to 4.5 billion gallon per year. That's a lot, okay? So most of the ethanol they produce actually right now is not for the whiskey you can drink, okay? They actually produce for the cars, for burning. Okay, we put added into the gasoline, 10% right now. So that's the first one. And the next would be Nebraska and Illinois. I think most of people, you guys come from Ohio. How much Ohio produce? This is Ohio. We produce about maybe 0.6 or 0.7 billion gallon per year. That's still a lot, right? So that's the production of the ethanol. They use this one to add it into the gasoline, actually, 10% to meet the criteria. Okay, so this is the countries we are producing. Most of the red in the red area is actually the state actually produce a high amount of the ethanol per year from the corn. Okay, so currently corn is blended with gasoline by gasoline 10%. Do you know actually on campus we have a car actually owned by university. They add gasoline inside. Do you know what's the maximum they added? You look at the car. They have the label on the outside. And university car actually they drive around the campus. I don't know which department they use. Maybe they from the sustainability. So it's E85. So those car actually is 85% ethanol. They drive around the campus. You can most time you notice some car park in front of the ERC center, the Mante center. They have the car actually. Okay, so ethanol price. We got to know how much we can make the profit, right? It's not that high, okay, but it's not that bad. So this is a fluctuation variance every year. This changes. So right now it's not that bad, right? So it's roughly between the 1.5 to $3 per gallon. So that's the price. Okay, right now the values. So this is and also people think that is if I added the ethanol inside the car, did I can drive more miles or less miles? You guys give me guess. So we replace 10% with gasoline, right? Can I drive more miles or less miles? Less. Yes, you're right. Less miles, actually. So people actually don't like. So some actually the gas station they advertise they have no gasoline, no ethanol inside, right? But very few. But I almost they require is 10%. So because of
That'll
the
be tax, so the government forces a certain amount or something? Or-
yeah, government force amount. So this is required.
Then
This
do they
company.
pay the ethanol producers and all? Are they subsidized? Or-
The original was subsidized, yes.
Oh, but not now.
No, right now I think it is federal is not subsidized too much now.
But they're required 10%.
It's required is still 10%.
So I mean, that's a guaranteed market. They can put any price they want on it, is that right?
Yes,
Because they have to do 10%.
they have to do 10%. Yes, that's right. Yeah, they have to add a 10%. Yes, yeah. So this one is to show is let's say MG. What's the MG? Okay. So this is the MG to show the numbers, energy content. So this one gasoline is 34.8 per liter. Actually, for the let me see the ethanol is 23.5. So that's why this one is compared to the gasoline actually is will give you less mileage. That's one kind of the consumption. So you can compare even the diesel is 38.6, right? So people actually like to drive diesel cars. If you drive the heavy ones, heavy duty cars, you better to add the diesels, right? So this one. And even the E25, this one is a little bit only 25.2. So anyway, it's still less than the gasoline. This is 74.8. And another one, we don't have too much liquid natural gas, right? And this one actually not that bad. It's 25.3 actually. People in other countries they use a liquid natural gas as transportation fuels, right? Okay, so that's one of it. Okay. This is the biomass we have. We have a lot. I told you we have 1 billion ton per year in the US. So the biomass is carbon based bioorganic materials. So that's come from the forest residues, agricultural residues, energy crop, and the algae as well. So you can see these trees. So biomass relatively simply is the clean renewable source of energy. Why we think that way? Because the biomass can absorb carbon, right? When they grow, they can absorb the CO2. That's the benefit. So that's the one research areas we are working on. But also there's forest residues and also these trees, they actually relate to another research areas in Cincinnati is pulp and paper. So one big company is in Cincinnati is called the International Paper. They are working on this. They produce a lot of pulp and paper and packaging for the Ohio. So that's one of it. Okay. And also P&G use a lot, right? So they use even add something for the diapers as well. So I want to show you some of the project I want working on right now. So this is the biomass, right? It's pretty clean. Okay. But you know how much actually the waste we produce, right? The solid waste, municipal solid waste. And one thing is we have how many of the dining hall we have on campus? You know, 4 or 5. Dining halls we have. 5, 6. Okay, so I went to one close to the ERC center, the 1920 center, that one, and it's just below the stadium. They can accommodate the students is 9,000 per day. So and then how much waste we can produce? That's a lot. There's 9,000 students. They use that one dining hall per day. Okay, and they produce a lot of the food waste, and including some of the packaging as well. So we actually have the one of the DOE project. So we want to separate this called MSW, municipal solid waste, and then to collect the organic fraction, like the food waste is organic, and also paper is organic, right? We want to use that one as a feedstock to produce the ethanol or biofuels. So that's a project. So this is show you the map of the total US the MSW generated by the category. This you can see most of them relate to the paper and paperboard, glass, metals, plastic, and food waste, and also some yard trimming, and also yard trimmings, rubber, laser, textile. So that's our project. We want to separate them and then use that one for the biochemical conversion to produce the biofuels. So let me see, give you some numbers. So how much actually the food waste, the municipal solid waste we produce in the US? So currently it's about 292 million tons per year. So that's one number, right? 50%, roughly 50%, could be more than that, actually was go to the landfills. So we didn't do anything. We just sent to landfill. Okay. So that's not good. So the landfill actually is the third largest source for the US for the. This is not a CO2, it's methane emissions in the US land. So this one is even worse than CO2, okay? Methane emission is worse than CO2. So that's a big challenge for us. So we have to reduce this one for the methane emissions. Okay, but MSW actually could be a good resource for us to produce the biofuels and the bioproducts. So that's, we are working on the one of the DOE project. I want to show you some pictures. So what do we do? Actually, we want to sort it and then remove the plastics to generate the high purity organic fraction from animal stuff. Okay, just show you some information. So you don't need to worry about too much of this one. So our goal is to develop advanced sorting and fractionation technology to separate organic fraction. So this is the 4 objectives. You don't worry about that. We design the screening. I want to show you the screening machine we have, and also we do the kind of mechanical mean, and then blending, and then to do the technical economic analysis, and also life cycle analysis to assess the process. How many people know the TA analysis? You heard of that? Technical economic analysis. I think if you guys go to do the final capstone project, you probably will do that. Okay, this is required. You have to do this analysis, called the TA analysis. Because if we build a plant, right? So we want to make sure the plant produce certain products actually can be profit, right? How much material you put in, how much energy you put in, and then how much the products you can collect, how much money you can make from selling product. So this actually you need to do the calculation. That's this one. Okay, so first I want to show you the pictures. We went to one place to do the first experiment at the real plant. So this one called the initial verification MSW sorting. It's called a vibratory screen because this actually is screen. You may cannot see that. These big pictures. So this is the real industrial size of screen we use it. It's traditional. So they vibrate and then they separate organic fractions. So when they actually did it, this one is actually it's called a green separation system in Cassville, Georgia. Anybody know this place? Anybody know Atlanta? Okay, this is 1 hour away from Atlanta. So we drove there and then we did the experiment. Okay. And this is the plan. They allow us to run the experiment there. So basically we produce the organic fraction, we reach the purity 50 to 70%, and also remove the plastic, right? About 50%. So that's our first experiment. So next one, actually we move back. So we want to build our own plant, actually in Cincinnati. So we built it. So this one, we are building this one is showing you the disc screen. So we purchase the equipment, it's called the screening equipment. And then we do the installation. We haven't done the initial test. So some of you guys are interested, you can work on the project maybe next year. So we can show you how to do that.
So how many people are involved in this project? Is it just you or?
We have about 10 people.
I mean, faculty?
Faculty, for ours is 3 faculty.
All at UC?
UC is 3 faculty.
Okay.
Then we have about another 5 from other university and also national lab.
Oh, okay. So it's a DOE?
Yes, DOE project.
Okay.
It's DOE project.
Right.
Yeah.
What are the other places? Oh, Oak Ridge? And,
Idaho National Lab.
oh, Idaho.
Idaho, yeah, Idaho, yeah.
Right.
So this is the equipment we purchased. This one is the red one actually is called the disc screen. It's a dynamic disc screen. So this is actually a box. So we install that, this one. So, and also this screen, you see this one is, disc screen is one part. And then we have to install the conveyor. This is the conveyors. So we install 3 conveyors. This is the feeding conveyors. And then at the bottom actually is the collection conveyors to collect the materials. Okay. And this is called the EcoStar. We ordered this one actually from Europe, Italy. So they ship us the equipment. This one called the EcoStar Hex Actor 5000. Do you guys guess what's the diameter of this equipment? And also what's the weight? Can you guys guess? 5,000 kilogram or pounds? Kilogram. Yeah, it's close. It's about 5 to 6 tons. Yeah, that's right. 5 to 6 tons. This heavy. Yeah, this one. Why is it called 5,000? Right? You have no idea. Yeah. So this is about 5 meters long, 1 meters wide. 5 meters wide. So we install this machine. Actually, you can see this one. Actually, we are using the 2 forklift. So one forklift actually cannot lift it. You have to use the 2 at the same time. Then you can lift it, and then install this one. So finally, actually, we created this concrete. We poured the concrete, build it, and then this one is installed on our facilities.
Where is this? Where is it located?
Is UC research facilities in Center Hill? You know?
Oh, yeah.
Center Hill. Yeah. Do you guys know the Center Hill? The one place close to the old PNG facilities. Winton Hill, right?
Something.
Winton Hill, yeah.
PNG.
Yeah, Winton Hill PNG facilities. So this one right now is located in at that place. It's a UC research facility. Yeah. So we built this one. Actually, we are not only building this machine here. Actually, we put a building on top of it. Right now it's finished. We put a building on top of this one right now. So it's finished. That's pretty good. Okay, I'll show you some videos. Hopefully it works. Okay. So I did the installation from beginning to the end. You watch the videos, I record it. So this is the installation. We have to put we missed the maybe beginning part, but still you can see how much actually we have done actually to install these conveyors. And probably on this side of the catwalk, yeah, we recorded almost everything here. So I like to show you guys the video. So this is really the engineering installation. I like to use tools to install each piece by myself and also with students. So that's pretty good. But anyway, so we hire some outside people to help us do the installation as well. This is the one. So this is the pre-screening equipment, and we finished the installation at the UC, the UC research facility. You can check. It's from the UC, yeah, Central Hill. You can find that place. And also some of the people from the construction company, even the planning, they help us to design drawing of the map of this installation and also the concrete design, including the building as well. So now we finish this part. So one quick question. So at the end, you see the color really become bright, right? Why in the beginning is dark? You know that in the beginning it's relatively dark. What's the reason for that? Who said that? Yes, you're right. So the guys, the engineers do the installation, they always want to start the work in the morning before 7 o'clock. So I have to be there at 7 o'clock to open the gate for them to do the installation. And also in the morning, 7 o'clock is pretty dark at that time. I mean, 1 month ago, it's pretty dark. So you can see this one. This is pretty cool. Okay. Anyway, I will show you the next one. So this one, this is another part of the video. I wasn't on the show, but I can explain at the same time. So this is another side. So we do the installation for this is on the top of the conveyor. This is the feeding. Okay, on the top of the conveyor. Actually, this one is pretty good. You can see the blue sky is moving, so it's beautiful, right? Anyway, so this approach, so we integrated the dynamic disk screening and mechanical milling and also ballistic screen. We haven't installed ballistic screen. The ballistic screen part will be done by the National Lab, Idaho National Lab. So they will do that. So we are doing the first stage. So this is actually only the first stages. So we were at the end, we will blend the kind of food waste with the cellulosic biomass. So previously you saw the biomass.
So ballistic screening means you throw the garbage at a wall or something? Or?
Yeah. It's a very vibrate screen. It's vibrate, it's through the garbage and then
They shoot the garbage.
No, yes, kind of. And then they will separate them based on the shape, the 2D shape, like the paper, and then 3D. This is 3D shape, right? 2D on the 3D. They can separate anything between the 2D shape and the 3D shape, the materials.
Oh, because of the aerodynamics?
Yeah, because of the aerodynamics. You shake it, shake it. Yeah.
Right.
So then the different will be different material will be separate. And also we
It's
actually
still pretty messy though, right? I mean, it's garbage.
yeah, it's pretty messy.
Yeah, I mean, it smells or it must smell.
You have to use the fresh one, otherwise it's pretty smells not good. Yes.
Okay.
But we just send our first round of materials to Idaho Lab. We collected it, and we after collected we dry it. So once you dry it, it's not doesn't have any bad smell. So we dry it and then send it to them. So they will do the ballistic screening with our dried samples. So that's much easier for them.
Oh, I see.
Yeah. And also safety issues. So we want to mix this one with the biomass, and then
So wait, how do you carry the garbage to Idaho in a van or something? Or?
carry them.
Well, you have to you dry the garbage
Yeah.
in Center Hill.
Yeah.
Then you put it into a van and drive to Idaho?
No. We put it into container, ship it.
Okay, all right,
Yeah, we put it in container. We seal the container and then ship it to them.
all right.
So this one is anyway, I shall explain the potential impact. Okay, so you guys learn some things. So we want to reach the 95% organic fraction MLW, and then for the biochemical conversion to produce the biofuels. Okay, that's the purpose. And then what's the issues we are addressing? We want to address the two issues. MSW have the big problem is sort of reliability issues and also heterogeneity. So every time you collect the trash, their component is different. So that's, and also you see actually this is a 3 conveyor. On the first conveyor on the top, you cannot see, actually you can see here. We install a magnetic separate. It's basically is a huge, this big magnet. So everything can be absorbed.
If you just took all the garbage and put it into a reactor, then you turn in the organic into fuel and liquid, right? So doesn't that automatically separate? I mean,
No, that's not separate. You can do that way put it into a reactor is by the gasification or burning process or combustion, right?
Yeah.
You can do that one as well.
Oh, but the plastic would gum it up.
Yeah. Sometimes they want to recover, they want to separate.
Uh-huh.
They want to separate the papers and also separate metals and also separate the plastic. And then the organic fashion, they also want to separate. And then the different parts can have different values.
Okay.
So yeah. And also, if you guys know the Rumpke in Cincinnati, they do the sorting as well, but they sort in the recyclable trash. You have 2 containers at home, right? So they only put the recyclable and then into their sorting machine. They have sorting as well, similar to this one. Yeah, they have a big system.
People could sort at home though, right, too?
Yeah, you can sort at home.
I mean, in other words, they could put their, in other words, like if you compost,
Yeah,
you already separate
Yeah.
that way.
that's much efficient.
Yeah.
Yeah.
People can be convinced to do that, I think.
But
They do it in Germany, like their bins are really strict and specific,
Uh-huh.
but the rest of Europe, I don't believe does it that way.
I mean, if you have, say you have garbage bags and you charge $10 a bag.
Yeah.
They have to use that bag, but if it's organic, they pay you $1. Like you could do it, you set up an economics to have the people sort themselves.
I think Europe do it better than us, because they do most of the recycling and also they try to reduce the trash a lot. Yeah, so that
It seems pretty messy. like
yeah,
that.
it's still not good smell and also not easy to handle as well.
Yeah.
Yeah. So that anyway, that's our project. We finished half of them, but you guys welcome to, if you want to learn something, you can do it. So we already finished the installation with everything. Now probably next spring we will operate this whole machine. We will open. Oh, next page. So now I give you guys, this is the first project, right? But actually the federal give much more money than we used to receive. So anyway, we receive about $2 million. So federal, they give me ideas. So this one from 2000, actually I reduced the pages of the slides. Actually they supported from 2007. This is from DOE, Department of Energy, from 2013. So basically they put $2 billion for called the Energy Security Trust. And they focus on the 4 things, okay? Natural gas, hydrogen, and also advanced battery. So you guys use now right now for the electric car, right? EV, and also clean biofuels. So that's another part. So we are actually was supported by part of this one as well. So from the even more significant from the 2023. So the DOE actually put the $490 million to increase bioenergy research, but this one only for the 4 centers. Okay. So the 4 bioenergy research center, unfortunately, we are not a part of that. Okay. Anyway, we didn't receive money from this pot, but we received from other places as well. Okay. So what's the target? So they want to produce a bioenergy. It's called a net zero emission economy. They call it bioeconomy by 2050. So that's the next 20 or 30 years of the research project or development. You guys can be part of that as well. Okay. So I give you the bioenergy center for this one. Actually, I summarize this information. So first one is called the Joint Bioenergy Institute. It's called the JBay. This is in California. Second one is Great Lake Bioenergy Center Research Center. You guys know this place, right? Where's the Great Lakes? 2 or 3 cities? State? Michigan, one of them. Any other? Ohio? Unfortunately, we're not part of it so much. Yeah, Ohio is part. Any other state? Big one? Illinois actually receive a lot of money from this one, and Wisconsin. So they supported 2 big universities, Michigan and also Wisconsin. It's called the Great Lakes Bioenergy Center, and then this one is Center for Bioenergy Innovation. This one actually is Oak Ridge National Lab in Tennessee. So they receive this money. And then the 4th one is called Center Advanced Bioenergy and Byproducts Innovation. Actually goes to the Illinois. So these are 4 ones. So each of them receive $100 million per year, each of them. And from the 2023. So and this one will be continued for 5 years. Okay. Similarly, I give you low numbers. It's actually from the Bioenergy Research Center from 2017. Previously, they supported 40 million per year, but now they almost tripled the amount for the research. Okay, in this area. So this actually is
How many years? So it's 5 years?
5 years from 2003 to 2023 to 2028.
So
Yeah.
each center gets $500 million.
Yeah.
It's a lot.
Yes, a lot. It's a lot. Yeah. Each of them get a half. 100 million dollars. That's a lot of money. So this one is, they also support some of the industrial project. This is showing the map. Each of these labels actually indicate the industrial plan they support it. Unfortunately, some of the company actually is bankrupt. So one of the famous one is this one. How many people heard of this one? Amyris? Amyris is one of the biotechnology companies related to the bioenergy. Initially was founded by Jay Kisley. People heard of his name? Jay Kisley, a professor, is working on the biofuels. So this one, they did pretty well, and they built several plants actually in Brazil and also in the US. But at the end, they didn't survive this year, so they bankrupt this year. I think it's about August or September. It's pretty good. And so I give you some information. So this one is called Beaucage, still there. Beaucage, I think that maybe is close to Idaho, and then another stage. What's the state close to Idaho? This one?
Nebraska.
South Dakota.
Oh, South Dakota.
South Dakota. Yeah. So they are actually close to the border. They are the one company, this one called Beaucage. They built a plant there. Actually, they produce the ethanol because originally they have the corn ethanol plant. So they just expanded. So they did this one. It's pretty big. So they want to produce 20 million gallon per year. Originally, this is Marion. Originally, I think in this one in Louisiana, they're planning to produce a salicylic acid. It's called byproducts. It's by the 30 million pounds. Let's give you two information. And okay, this is two actually. So first picture show you the project and actually the company name and then the location. This is the skills you got from Kevin. You know the skills have the lab skill, pilot skill, and then the commercial skill. This one is commercial skill, and also they have pilot and for the demonstration. Demonstration is kind of a little bit larger than the pilot, and sometimes it's safe, right? So you got to learn something from this one. And also the conversion technology for the biochemical conversion and also thermochemical. Thermochemical have two. One is called gasification. The other one is called pyrolysis. You guys heard of that? What's the difference? Pyrolysis and gasification.
Solid and gas.
Oxygen.
One is with oxygen, one is without oxygen. Right?
Yes.
Great, thank you. Yeah, most are related to the oxygen or not. Okay. Biochemical is easy. Just with microbials and enzyme is by the fermentation, right? Okay. But I tell you the truth, okay. If you guys learn the fermentation, is easy to find a job right now. So almost every month, people sending me email asking for people to graduate with the fermentation experience right now. If we can do that, yeah. So they requirement a lot right now for the fermentation engineers. So this is the second pages. Actually, I want to show you one. So one of the actually from the Ohio. So this is a tornado. It's the Renewable Energy Institute of International. Anyways, I haven't been there. I don't know the place, but this is one of them represents the Ohio in this part. Okay, this is the thermal chemical conversion. I told you already the gasification pyrolysis. You know the difference. But this is easy, right? You just throw everything inside and then you heat it at a high temperature. One is you maybe provide oxygen, that one you don't provide oxygen or air. That's easy. And second part actually is called the biochemical. Biochemical, you have to do the pretreatment and then you collect the sugars. And also after the sugar release, you can do the fermentation. You can generate the acid or biofuels from this part, okay? After that, you have to do the separation as well. You know what's inside of the tree, right? The fiber. Actually, they are all glucose. Okay, but we cannot digest that, but a cow can digest that, right? The grass. What's the difference? Why we can eat corn, right? We can eat corn, we can get the sugars, but we cannot get the fiber. You cannot eat the paper, right? What's the reason for that?
Also like for stomachs.
Yeah, but there's made of enzyme. But what's the chemical structure? The glucose actually link them together. The fiber actually is thousands of glucose linked them together, right? The fiber. So the coin also is thousands of glucose. Glucose is 6 carbon, you know that, right? You guys learned from high school. So 6 carbon, so one structure, the link all of them together, it's become polymer. I think Greg, Dr. Beaucage actually probably know much about the polymer. So that's actually link them together. But there's the linkage called a bond is different. Glucose linked, one glucose linked to another glucose. So one is alpha, one is beta. So they twist it. So one is easier to be digested, the other one is very hard. So everything is hard actually is the paper, the trees. Okay, and the coin is easy to be digested. That's why I call it the starch. Okay, starch and the cellulose, they are basically the same. They are composed of all the glucose inside. Okay. Anyway, I will show you something later. Okay. So what do? We will do the biomass pretreatment, and then we will do the enzymatic hydrolysis. And this is the fermentation. I will show you some fermentation. This actually is one of the pictures that I took from our fermentation samples. You know the fermentation, right? What's the inside of fermentation? Normally we add it yeast. Yes. You do the baking at home, right? You make the bread, you add the yeast. So this is the yeast. Okay. This is exactly yeast. You know the yeast always has some a top of a kind of small part on the top. This part. Yeah, and also this part as well. What's that called? Yeast. They always have some scar on the top, on the surface. What's that called? Who learned the microbiology? No, nobody. Okay, you guys are all. I think you guys reached the age can drink the beer, right? Yeah. Okay, you guys have know the beer. They have the commercial name called the Bud Light, right? Bud Light. This actually called bud, B-U-D. This is called bud. So the yeast, they produce the next generation, they separate. So once the one will separate become 2, they will generate a scar on the surface. That's actually called a bud. That's why they use this yeast for the beer fermentation, right? So that's why it's called a Bud Light. Where this comes from. Okay. Yeah, that's called Bud Light. From here. Okay. That's the yeast. So now you can see this is actually show you the structure of the biomass, the cellulose. So most of it is cellulose, hemicellulose, and lignin. So cellulose is the paper, the white part, right? The white part. So you can see each individual actually glucose and link them together. This one actually is alpha 1,4 linkage. Anyway, I teach them the chemistry. So this is alpha 1,4. And then this have a hemicellulose. And also they have lignin. Lignin is well, you don't have this one. You go to the restroom, you see the brown color of the tissues. This one actually is lignin color. This is the structure of the lignin inside. Okay, to show you. So this is another picture to show you the plant cell wall. The plant cell wall composed it's called an S1, S2, S3 layers. That's actually inside actually the cellulose, and then link them together the hemicellulose. So that's the yellow part, and then outside is covered by the lignin. So what's the popping process? You know, we have we have a popping plant actually close to us, actually in Kentucky. So they actually require most of the chemical engineers to do the work as well. So what's their purpose for the popping? They remove the lignin. So once they remove lignin, it's become white. This pulp can make paper. So that's called pulp and paper. Pulping and paper making process. Okay. Anyway, so this is to show you the cellulose. This one show you the beta one for linkage, and also this is called the degree of polymerization. Maybe a professor teach you guys before. This one called the DP, degree of polymerization. This one is more than 10,000. Okay, so typically for cellulose, and also for hemicellulose is smaller. It's about DP is 150 to 200. So that's why easy to be break. And this is the lignin structure. Lignin is one thing I want to know. A lignin is called phenylpropene. They have the benzene inside. So I would say most of the people don't like their popping plant close to their neighborhood. They always produce bad smell. Okay, so that's mostly related to this part. Lignin and also some of the dioxin toxic compounds. That's also come from this one. Okay, But right now they do pretty good for the wastewater treatment. They can really get rid of them. Okay, so that's a. So what do we do for the biochemical treatment? So we do the pre-treatment. Actually, it's popping process. After that, we add enzyme. So those enzymes can break the fiber into sugars, and then we do the fermentation. So you guys know the yeast, right? Yeast have some scientific name. It's called the Saccharomyces cerevisiae. That's the Greek name for the yeast. This one to show you the pre-treatment process. They have different process. I just want to show you some pictures. This one I took it from the National Renewable Energy Lab. It's a continuous process. It's actually is a chemical and a mechanical deconstruction process. So they use called the de-acetylation and a mechanical refining process right now, actually to produce the pulp. Okay. This is to show you the pictures, and this one is pre-treatment chemicals. They have fitting, and do you guys know this unit? Extrusion. Singular. Yes, you're right. It's sometimes they give another name. It's called auger reactor. Just like extruder. Okay. Feeding materials. And then once it finishes, you can collect the materials as well. Okay. And this is produce a high concentrated sugar stream. This is actually just by the enzymatic hydrolysis. They are using in the reactor. So that's easy. So how to get the enzyme, you know that? Actually, you can get it from this tree stumpage, right? What's the green color on top of the tree stump? You gotta know that. Yes.
Sap.
Moss.
Second.
Moss.
Close to moss. Something.
Lichen?
Second.
Lichen?
Yeah, it's close to that one. Any other name? You can eat. You can eat.
The answer you can.
You can. Yeah.
Mushrooms.
Mushroom. Mushroom. This actually is mushroom. So mushroom, fungi, right? Mushroom actually was used to produce the enzyme. This actually is the enzyme can break. They can break the tree, right? So of course they can break the fiber. So that's why we get the enzyme coming. So actually, if you know the P&G, right, they use a lot of enzyme added into the detergent. Some of the enzyme actually produced by this kind of fungi. So they use fungi to produce enzyme and then mix in the detergent. Okay, so if you see the detergent right now, they have some small particles, green color. Actually, they mix it, they coat it with the enzyme inside for their detergent. So these are original pictures to show you the enzyme actually to break the cell wall. This is cell wall. You can see quickly they break it. So once you add enzyme, the cell wall is gone actually. So that's to show you the information for that. Okay, so
What's the time scale on the, like, how, was that real time? Or?
the real time.
Oh, that's
But they actually they probably did it on 48 hours. They
Oh,
ran
okay.
quickly. Yeah, 48 hours. Yeah. So they can put the camera on top of that and they can see it. That's pretty cool. Yeah. So at the end of the day, we want to do that is do the fermentation. So glucose was consumed, and then this one of them we actually in our lab we produce called the butanol. Butanol actually produces, so that's our target product, liquid fuels. Okay. You know how many carbon inside the butanol, right? Yeah, 4 carbons. So it's better than ethanol. Ethanol only have 2. So we produce 3. Okay, so this is why it's very useful. If you guys do the capstone design, this is a required flowchart. Okay, tell you that now. So this flowchart actually is, well, I think probably created by the Aspen. You guys know the software Aspen. You can use the MATLAB as well. But this Aspen is mostly for the process control. So they use actually design this one. You have unit. This one is pre-treatment, and this part is for the enzymatic hydrolysis and fermentation. And then we have distillation unit. And this one actually is for the boiler and burner, so to recover the energy. So this actually is very useful for your capstone design project. Anyway, it's available. See, this is the ethanol production. The engineering analysis actually is the TEA analysis. I will show you. So minimum ethanol selling price original was 2.15 per gallon, and also you see the enzyme cost is about 74 cents. Yeah. So So that's the original calculate data. So this is to show you the chemical compositions. And also based on this one, we can calculate the biomass cost. So this is original with a dry ton, the biomass is about the $48 per ton. Okay, the biomass, like wood chips, the values are available. This is to show you the enzymatic hydrolysis conditions. I will just jump it, so you don't need to know that. This actually is fermentation. How much, we use the microbials actually can produce the butanol, right? So this is the butanol production, but at the same time, we can produce the acetone as well, and also the ethanol. So this is kind of special, the bacteria is called Clostridium. They can grow and then they can release the products. So the butanol, acetone, and the ethanol as well. So this is the ethanol distillation and also separation process. I think you guys learned a lot for this one, how to separate the ethanol by the distillation. Okay. So let's show you this is the real one of the sugar plants called the sugarcane ethanol plant in Brazil. So they actually get the sugarcane, they crush it, and then they do fermentation. By the distillation, they generate ethanol. And then the ethanol mixed with the gasoline they use for the cars, right? And this actually the cycle. Of course, this one will generate carbon dioxide and then go back to grow the sugarcane as well. So this is called the carbon dioxide and the water absorbed and then convert the sugars. This one then fermented to the ethanol. So that's the whole process. That's called a life cycle assessment research. This will show you the energy input and output. This is very good discussion. I will leave it here. So I will leave it here for the byproducts. Okay, so this is one final one. So what's the target for the called the replace the whole barrel? So this is the barrel of the crude oil. What do we want to generate? This one is called the diesel is 24%. And then jet fuels is 8%. Gasoline is 42%, and then others actually 25%. So what do we want actually is to produce the hydrocarbon fuels. It's called the drop-in fuels to replace the gasoline and also diesels. So right now, most of the people actually interested by the new is called the jet fuels. So that's what we are working on this project right now. Okay. Any other questions? Thank you.
Questions?
Any questions?
So the jet, are you saying you can make jet fuel with it?
Yeah.
It'll be a mix or pure.
It's a jet fuel is this way. So we make the ethanol and the butanol, right? So one is C2, one is C4. So and then you link them. So once you get the butanol, you have C4 carbon, right? You link it, reach more than C10. You have more than 10 carbon. That linked fuels actually can be counted as a jet fuels. But you have to do the chemical conversion as well. So it's not like you can use the butanol directly as a jet fuels. You can convert it to become C10 or C12, the liquid fuels. They do the hydrogenation to remove the oxygen, and then they have to link them together.
I see.
Yeah. To make it a jet.
These slides will be like on your website.
Can you send a PDF or something?
Yeah,
like
I will
that?
send you. So
Yeah,
you can.
I'll put it up. Yes. Yeah. Yeah, it's pretty interesting. I think. So, any of you guys want to do the project with Maobing or?
Yeah, you guys feel free to contact me. You can find my name from the department.
Are you sponsoring Capstone?
Not officially for sponsor Capstone, but you can work on the Capstone working with my project.
You can tell it'd be pretty exciting to be in his lab. He's always like.
Yeah, but you can work on the
it's
bigger
like-
machines if you want.
He's got so much energy. Like
You can work on the bigger machines. So that's big.
you won't fall asleep in that lab. You know, it's like.
The sustainable aviation fuels, so a lot of it is just stuff.
Oh yeah, that's good. Yeah, then you probably have a lot of relevant information related to this one. Yeah, that's good. Yeah, its a new name is called SAF. The sustainable aviation fuels. Yeah, it's called jet fuels.
Oh yeah, we're out of time. So yeah,
Great.
thanks for coming. Yeah.
Thank you.
Oh, thanks. Yes, you're always like an exciting speaker to hear.
I hope, I hope.
Much energy. I feel like, if I was your kid or something, you know, I would know all of my math tables, like, what's 5 plus 10, what's 5 plus 10? Yes. All right. Not be laid back.
Yeah.
Good. Yeah, okay, yeah.
Yeah, I'm Annie.
Okay.
I'm Taylor.
Yeah, I emailed, Christoph.
Yeah.
He hasn't got back. I'm trying to talk to him today.
Right, and then if we want to do like virtual or something, it's like, like,
All right, but it'd be good to see the.
Yeah,
stuff.
definitely.
Yeah.
Yeah, we got a message from Teal that we have to have a preliminary report by December 7th. He just told us this morning that we have to have one. So we can like start looking at stuff also. Or TSA more like, oh, it's one on the shares or anything.
Yeah, he has a lot. Actually, we have like a proposal thing for it, so
Okay.
that might be a good place. But what does he want, 1 page?
It's more of like. Okay, cool. Yeah, so. My expectations are you'll define the scope of the project, identify process chemistry for early thinking about process alternatives for the process objective, complete a rough overall material balance, and have reason to believe that it's reasonable from an economic perspective, so just like an economic. And then principal hazards of the process,